So we're looking at relative velocity in two-dimensional space. So like all the things that we did till now to this point, any two-dimensional aspect we dealt with one dimension, combine the one dimension, other one dimension, and we got the result. Here too we are doing the same. So the step is to break the velocity or whatever it is that we have to figure out, break it down, convert one dimension to two dimension to one dimension, then figure out the velocities. Since we are talking about relative velocity, we figure out the velocity in x and y component, combine them. So I'll give you guys an example, a simple example actually. Okay, a boat can travel 10 meter per second in still water. The captain wants to cross a river which is 80 meter. Let's analyze. We have a boat, it wants to cross some distance, 80 meter, and the current flows downstream. So we have water current. So basically we are looking at something like this, and we have water flow. So we have this to be 10 meter per second, and we have this to be 2 meter per second. So basically the boat is traveling, say in y axis, it's traveling with a speed of 10 meter per second. In x axis, it is traveling at with a distance of 2 meter per second. So your relative velocity, right? Relative velocity of boat with respect to ground would be something like this. It would be 10 or 2 I cap. Let me write this way, 2 I cap plus 10 j cap, provided I take this as positive direction. That's it. So that's your velocity of this boat. If the captain happens to try to move across the river in this manner, but what happens with time? With time, he will go this way. Reason being, the engine is pushing it forward, but your river will push it to the right. Even though the engine is pushing it forward, the river will push it to the right. As a result, it will go something like this, and he or she will end up at this space. Okay, so the actual velocity would be, the magnitude of the resulting velocity will be 2 square plus 10 square to the power of 0.5. That is basically square root of this. And the angle say theta, I'll take theta being the angle with respect to the 10 meter per second. So I'll write that. So if that is the case, okay, so this is your 10 meter per second, this is 2 meter per second scenario. This is your resulting velocity. So if this is theta, the opposite is 2 by 10. So theta is equal to tan inverse of 1 by 5. So this is with respect to what is this? I think with respect to direction, crossing path, or with respect to y-axis. Okay, it's as simple as that. So basically, angle part is a bit of extra over here. If not, everything else follows the same suit. So consider your y component, x component individually. And since everything is given over here, I directly came to this point. If not, you might have to calculate and all of that. And then you figure out the magnitude and direction in this way and done. Okay, that's it. So we just combine each component and then you have the resulting velocity like over here. And then magnitude and direction, that's a simple set of calculations. Okay guys, so you can pause and have a look. Anyways, we'll do a lot of problem, then we'll get a better hang of it.